Open your book to page 34. Today's lesson is on relations and function. If you look on page 34, the blue box, it gives you a definition of a relation. It says a relation is a set of ordered pair of numbers. And the first number is called domain, and the second number is called a range. And so example, if you look at example 1, instead of using R, it's very confusing. I'm going to use S, stand for the relationship. So you got S equal to -5, -5, -4, 2, -2, -2, and I'm going to stop over here. So this is an example of a relation. So again, relation is a set of ordered pairs. Ordered pair means you got the two numbers. Now, in this case, and you want to find a domain. So D stands for domain. So domain would be the first numbers would be -5, -4, and -2. So that would be a domain. And again, the reason I changed this to using S because usually R is used for range. So that's why I'm using the R over here. So this R is not the one in the book. Okay. So R stands for range. Range is your second number or the Y. So in this case would be the -5, the 2, and the -2. Okay. So domain is your first number or the X. Range is your second number or the Y. And so if you using the second half of this relation, so if let's say S equal to 0, 1, 0, -3, 2, -4, and 3, 4, for example. So in this case, the domain would be, again, domain is the first number of the X. So it would be 0. Now notice it's already, the 0 is repeated, right? So all you need to do is write it once. So domain would be 0, the 2, and the 3. And the range would be 1, -3, -4, and 4. Okay? So again, domain is your first number, range is your second number. And when you have ordered pair, this is called a relation. Okay. Now, when you go to page 35, the blue box, the function. It says a function is a relation with in which the two ordered pair have the same first element and distinct second element. So what it's saying is that when you look at a relation, if the first number of the 2 points are the same, okay, then it's not a function. So like this one, see, if you just look at the first number, so the first number is all different. So this is a function. Okay. When you look at over here, see, these are two of the same. So if you look at the first number, two of them are the same with the second number. So right away, when you have the two of the same number on the first on your domain, then this is not a function because of these. So again, they cannot be the same. Next thing is you need to know how to graph things. So let's go over some examples. Like if you go to page 37, example 6, you have 2x plus 3y equal to 6, and to graph these. So the most basic way to do this is you make a table like in the book and you plot points. Get points and you plot the points and you connect the dots. Okay. But this is the linear equation. This is the standard form, so you can do it faster from your algebra 1. Okay, you can let x equal to 0, then the y will equal to 2, right? And then you let y equal to 0, then x will be equal to 3. And so from here you can just plot those two intercept points. So 0, 2 over here, and 3, 0 over here, and you connect that, and that would be your graph. So this is much quicker. So that way you don't have to make the table. Making a table is like your last resort. That's the most basic primitive way. But if you can do it faster, then do so. Okay, now next thing is to able to tell if it's a function or not by looking at a graph. So whenever you have a graph, just using examples, if you're giving graphs and you want to see if it's a function or not, all you do is use a vertical line test. So again, this is not in your book. So let's say if you have a graph looks like this, and you use the vertical line test. So whenever it crosses over more than one point, it's not a function. So this is a function. Now if the graph is going like this, again, you see over here it touches 2 points. So this is not a function. So again, so you have to use the vertical line test. And if you have an ellipse like this, so again, if you go over it, so this is not a function. Okay, and if you have things like this, in this case, it only passes 1 point, so this is a function. So again, it's very simple. You just do the vertical line test. Now, some graph you may have something weird like this, and you may have different things. Okay. So again, if you do the vertical line test, so everything's all good. Now over here, notice there's an open circle, right? And so it intersect with that, so that's okay. Same thing over here. So this is called a piece function, right? So like there are 3 pieces. So this is the piece function. And so in this case, this is a function. So again, it's very easy to tell if it's a function or not by just using the vertical line. Whenever it touches more than 1 point, okay, then it's not a function. So like this one here, it touches more than 1 point. It touches more than 1 point. So whenever it touches more than 1 point at any given time, anywhere on a graph, then it's not a function. Okay, let's go back to graphing a little bit. Let's talk a little bit about absolute value graph. So let's say if you have y equal to absolute value of like x plus 3, for example. So to graph the absolute value, what you do is first you want to ignore the absolute value. Just pretend it's not there. So just graph these. Okay. And so from here you just graph. And again, you can use many different methods. You can just make the table, okay, or you can just use slope-intercept form. Either way. So if you use a slope-intercept form, okay, the intercept is 3. So you go 1, 2, 3. So they start up, and the slope is 1. My slope is 1, and so you go up 1 and go over 1, right? And so that would be your graph. So your graph will look something like this. Okay, so that is for that. Now let's take care of the absolute value. See, when you have absolute value, that means absolute value means positive, right? So from these means y equal to positive number. Okay, so y cannot be a negative number. So notice when you get down here, y become negative. So what the absolute value will do is that it will flip it over. So instead of going down, this will get flipped up. So your graph will look like this. So that's what absolute value will do. So first you ignore the absolute value and you just graph the straight line. And then to take care of the absolute value, you just flip this over. So just flip this over, just reflect. And that would be your absolute value graph. Okay. So these are some of the review on your basic graphing. Now let's go over one more example. Let's go to page 40. And let's do number 5. So you got y equal to f of x, which means the y. Okay, now these are 3 parts. So what it's saying is that y equal to x from 0 to 1. Okay. And again, the way to graph this is you just substitute, right? So when x equal to 0, and when x equal to 0, so y, again, so this part is y equal to x. So when x equal to 0, y equal to 0. Okay, so again, you make the table for each part. So when x equal to 0, y equal to 0. And you do the boundary, right? Do the endpoints. So when x equal to 1, y equal to x, so y equal to 1. So from here you get this point. But you got to be careful. Notice there is no equal over here. So when you graph with your open circle, right? And this is a closed circle. And so you're gonna, and this is a linear equation, right? Because it's first degree. Okay, so that's that. Now when you're doing this part over here, again, you do the making the table, and this is y equal to x squared between from 1 to 3. So when x equal to 1, 1 squared is equal to 1. When x equal to 2, 2 squared is 4. When x equal to 3, 3 squared is 9. And again, this is going to be an open circle. So from here, so for this graph over here, you're going to fill in, so 1, 1, so you're going to fill in that circle. Now, when x equal to 2, you get 4. So you're going to get this one right over here. When it's equal to 3, you're going to get 9. So it's way up here. So this is a parabola. Okay, so it's kind of like this. And again, there's going to be an open circle right over here, right? Because of that, there's going to be an open circle. Now, over here, when x is greater than 3, you're going to get this over here. Okay, so again, you can make a couple points. Right? So when x equal to 3, so you substitute 2 times 3. 2 times 3 is 6 plus 3 is 9. Right? And so you're going to do that. And then when x equal to 4, 2 times 4 plus 3 give you 11. And so this one would be a straight line again. Okay? And so it's going to be a continuous one. So this is going to be like a weird graph like that. So it'd be straight, curve, straight. So that's what you need to do with this is called the piece function. Because it's made up of pieces. Okay? So that's what you need to do. You have to do each one individually, and you have to pay attention to the open circle, closed circle. Okay? In this case, they all connected, but in most of the cases, they don't connect. In a lot of cases, you're going to get graph that looks like this. There's going to be jumps. Okay, so just be aware of that.